welcome back. So this is questions number 1268. As you can see here in the lead code, the question is saying search suggestions system. Okay, so I have the data here, as you can see. Okay, so let's understand what it is saying. Okay, what the question is saying. Hmm? Actually, in the question it is saying that you are given an array of string that is known as product. Okay, and a string search word. Okay, so we have a array of string, we can say we have a array of string, and that is known as product. Okay, and a string search word is a string. Completely understood? As you can see here, the product is a array of string. Okay, and there is a word search word is a string. So it is saying design a system that suggests at most 3 product names from the products after each character of search word after each character of search word typed. Okay, so what is saying, design a system that suggests at most 3 product names. How many? 3 product names from product after each character of search word after each character of search uh, word. Okay, which is typed. Okay, suggested products should have a common prefix. What should have? A common prefix would be there. Okay, with search word. If there are more than 3 products with the common prefix, return the 3 lexicography minimum products. Okay, okay, how many? 3, we can include it. Okay, product. Return a list of lists. What we have to return? List of suggested products. List of suggested product after each character of such word is typed. So we have to return a list of lists of suggested product. Okay, whatever we have typed as a search word. Okay, so let's understand one example here first. So we have products. Okay, in the products, what we have these things. Okay, what we have? These things. Product equal to mobile, mouse, monopod, monitor, mousepad. Okay, so we are going to search as a string mouse. What is mouse? What we have? We have mouse. Okay, here. Now, as you can say, we need 3 product, right? We need 3 lexicograph minimum products. Okay, and or you can say 3 product names from the product. So if anyone is typing mouse, right? So what are the things will come as a common prefix? As you can see, it can be mobile, mo, right? Money, bot, monitor. Okay, mo, right? Mo is common in everything. Mobile, money bot, monitor. Okay, then it will come mouse, mousepad, mouse, mousepad, mouse, mousepad. Correct? So these are the possible output will be here. Okay, so let's understand the explanation. What is saying? Product sorted lexicographically like mobile, moneypot, monitor, mouse, mousepad, right? After typing M and MO, after typing M and MO, all products match and we show user mobile, mobile bot, monitor. After typing MOU, what will have? MOU, MOUS and MOUSE mouse. Okay, the suggested will be mouse, mousepad, right? So how many should be there? 3. What? How many we have? Mouse, mouse. Okay, so this is the 3 things it is saying. Okay, I think you have understood. Got it? Another we have product Havana, right? Havana, and the search is Havana, single word. So how many letters will be H for H? Okay, for H a exact word we have. How many letters we have in the Havana search letter? That time we have 1, 2, 3, 4, 5, 6. Here see how many letter we have? 6 character we have in the search word. That's why 6 output is here for the exact match due to. Okay, and now we have products that have bags, baggage, banner, product, banner, box, clothes, and the search word, right? So these things we have. That's why baggage, bags, banner, these things are coming. I think you got it. So what we have here, right? So there is the first approach we have, the binary search, right? So what intuition we have? Since the question asks for the result in a sorted order, so let's start with the sorting product. Okay, and advantage that comes with the sorting is a binary search. Okay, and we can search for the prefix once we locate the first match of prefix, and all we need to do is to add the next three words into the search result. Okay, what are the result we have? If there are any, since we are sorted the words beforehand, right? So what we have algorithm here, what we have to do, we have to first sort the input products. Okay, in the next step what we have to do, we have to iterate each character of the search word, adding it to the prefix to the search, right? What we will do, we will iterate each character of the search word, adding it to the prefix to search for, right? As we have seen in that case Havana, we have how many characters? We have 6 characters, and we have gone through how 6 times, and we have 6 Havanas in a output result, and we have added in a output that is known as the prefix, right, of to search for. Okay, and the third step what we will have, after adding the current character, right, after adding the current character to the prefix, binary search for the prefix in the input, right? After adding the current character to the prefix of binary search for the prefix in the input, we will use as, and then write what we have, add next three strings from the current binary search start index till the prefix remains same, right? So we will, what we will do, we will add next three string from the current binary search start index till the prefix remains same. Okay, and the last one, we have another optimization that can be done in reducing the binary search space to current start index. This is due to the fact that the adding more characters to the prefix will make the next search index result, right? As you can see, at least greater than the current search index. As you can see here, so let's, this is a class, right? What we have, this is a class, we have solution, and what we are saying comment is here, equivalent code for the lower bound in Java, right? What we have to make, we have to make lower bound, right? In the lower bound, what we have, products, we are giving products and start and word, right? So as you can see, we are starting from int I start, j is product dot length, and whatever we have mid. So if while I is less than j, while I is less than j, start is less than the last length of the products, right? We will get a mid, right? I plus j by 2. As you can see, the two pointer algorithm we have, right? The binary search you can also know. So in the binary search we are using, right? So product of mid is compared to the product is greater than equal to 0. That time j equal to mid, else I equal to mid plus 1 we will do, and then we will return I, right? So what we have suggested product. Here you can say product search word, right? So it will sort the element, then this is the result. We will add all the output here. In start is equal to 0, bs start equal to 0, n equal to product dot length. So a string prefix equal to new string we have, and we will make character c search word to char array, right? And prefix plus, then we will add all the possible data what we have, right? As you can see, we are passing start index, right? And whatever list we have, we will get the start, and we will add the result here, right? And you can see we will calculate the result, and then we will result dot get, we will add the products, right? And finally we will return. Okay, so these are the steps we have to follow. In this case we will get o n log n, right? These things we will get. So let's see how the code is here. Hmm. As you can see here, we have a solution, right? Class. In the solution we have lower bound, it will return the equivalent code for the lower bound in Java, right? So we will product, we are passing a start index and the word we will pass, right? So we will get a start and end, right? While start is less than equal to end, we will get mid, and we will check the product is compared to word, right? If is equal to greater than equal to 0 means we have j equal to mid, right? We will get the exact items, and then else we will make mid plus 1, right? And it will return I, right? Whatever the data we have, we will return I. And same thing what we have to do, we have to go through one by one character here, right? This is the main function suggested product we have, and we will return the list of string, right? So we will pass the we will make a for loop, and all character we will go through of search word, right? We will add prefix one by one character we will add here. Then we will check all the time, it will go to the lower bounds and it will calculate all the start, and we will add the result here, right? In the result. And there is other, we will start I equal to start, and I is less than equal to mean, right? Start plus 3 something we have, start plus 3, and comma n. Let's understand what we have. Actually, the add the word with the same prefix to the result. Loop runs until I reaches to the end input, or 3 times till the prefix is same, right? We have to make 3 possible outcomes, right? That's why we will make start plus 3. Okay, and then, and these are the condition we have. Product length should less than equal to prefix dot length. Product whatever we will get the substring, and it should be less than equal to we can say prefix. So if that is there in the case we have, so we will break, otherwise we will add we'll get the size minus 1, whatever we have data, right? We will add the product over result, right? And we will return the result. So this is all we have. If you have any doubt, please let me know. As well, we have another approach. Let's go through first that one also. So there is a, we will no need to go through complexity, binary search complexity. There is a tree concept, right? Try concept we have plus DFS. So whenever we come across questions with multiple string, it is the best to think of try, right? And can help us. What we need here is a way to search for all the words with a given prefix. This is a well-known problem that try can solve. The question also asks for a sort of result. If you look closely, uh, try word is represented by its pre-order traversal. It is also worth noting that a pre-order traversal of try will always result in a shorted traversal of results. Thus all we need to do is limit the word traversal to 3. The question using try is we have search word, design, add, and search words data structure. Okay, so these two questions we have will go through later, right? 79 and 211. Okay, this is based on try. So let's understand this is a root, right? We have, so there is HER, right? And then there is a TIMIMS, right? This is the letter. So let's what says him, her, his, team, hi. Actually what we have to do through the algorithm, we will create a try from a given products, right? And products input, iterate each character of the search word, adding it to the prefix to the search. And then in the third we will do, after adding the current character to the prefix, we will traverse the try pointer to the node representing prefix. Now traverse the tree from the current pointer in a pre-order fashion and record whatever we need encounter a complete word, right? And then we will limit the result to 3 and return DFS once reaches this limit. And then we will add the words to the final result, right? So this is a, let's see, this is a class. We will keep all the things one place. Okay, as you can see, so this is a custom class, right? We have a class, okay, tree, and we have a node, right? In that, so node will contain is what false, right? What is there or not, and then all the children we will contain. Okay, so node is of 26 character we have, right? And that's all we have. So node root and then current, and then we'll take a result buffer of string. Okay, so let's understand, we will make a DFS with the prefix. We will pass current node and word. It will check the size, buffer size should be equal to 3 maximum, and otherwise if we have, then we will return. Else what we will do for the each 3 possible outcomes, we will make current is what, right? Then we will made a result buffer dot add. Okay, and then we will call DFS, in which we will go through character A to Z, right? We will make all possible paths, and then we will go through one by one character, and we will add one by one. Okay, what plus C, and we know try is nothing but a new node, right? We will add, and for the wide insert, what we will do, we will go through the root is whatever we have current we have, and for all the characters, right? For all the characters, what we will go do, we will check if this is a null, then we will add, otherwise we will get the current. Okay, similarly whatever we used to do in the try, right? Then current is what, then we will return true is equal to true. Else what we will do, we will go through the result buffer equal to new array list string we will go through. Okay, and for that we will check one by one character. If equal to we have null, then we will make we will return, else we will get to the current, and then we will call DFS prefix, right? So this is the code we have, right? So as you can see here in this bound, I think here I have, let me go here, yeah, this one. So we will go to the try, for the try, right? We have try, then we will go through the class node, right? And we have is what and the children, then we have current and root, we have result buffer we have, we will add all the result buffer. Then we have DFS we have, in which we will pass the current and no word. If the size is equal to 3, we will return, otherwise we will add into the buffer. What we will do, from we will run the DFS for all the possible paths from character A to Z. We will go, we will check if equal not equal to null, then we will check a DFS with prefix. Okay, and so it will give you result buffer, and then we will insert, right? So for all the we will insert the string in try, in which we will point to the current root to the try, right? In which what we will do, for all the character we will check, if not there, then we will set the value, otherwise we will maintain current. If current is a word true, then what we have to do, we have to get words starting with whatever we will pass the prefix for all the character. We will check if this is available, otherwise we will return buffer, right, if equal to null. Otherwise we will maintain current similarly fashion. Then we will check with the dfs, right, prefix. If it is available, we will have the result buffer. And whatever the class we have, right, we will make suggested product, we will pass product and search word. Internally for all the product we will insert into the try, and we will get the prefix as a new. We will update the prefix here for the search word, right. We will have the all the character will we will iterate through the for loop, and then we will update the result dot add, and then we will add try dot get words starting with the prefix, right. So it will add the prefix here, and we will return the data. Okay, so please if you have not understood or if you have any doubt, please make a comment here, or either you can go through again the video and see whatever what position you have not understood. Try to make the starting, right. So very simple things we have. We will make a try class, right, in which we will make a node with, we will make a dfs with the prefix. We will with the prefix we will get all the three suggested list in the result buffer. And after that we will, what we will do, we will from the current to insert the data on the try, what we will do, for all the character of the string we will go through the character. If is equal to null, then we will set the value. Otherwise if we have to, we will maintain the current, right. If, and then we will make all the current is word as a true. Okay, now we have get a state and get words with the prefix name, right. For the all the character we will get like the same, we will have the result buffer. Otherwise we will return the current, and then we will check with the prefix. If we have the data, we will return a result buffer. So this is very simple things we have. And especially you have to maintain this class suggested class, as we have to write the method product. We will get the product and the search word, right, and you will get the your prefix, and it will return you everything. That's all we have, and it is very good. Thank you so much.